Hi everyone, welcome to this video. Welcome to Greatful Learner. My name is Deepak Kumar, and today's our topic is engineering mechanics. So discuss all about engineering mechanics. We are used in mechanical engineering and also civil engineering and law, and some types of concept which include to engineering mechanics. We have learned the things and the properties and the applications and the future description also. So let's discuss. We are going to the screen. So first of all, engineering mechanics. So engineering mechanics basically the engineering mechanics in this presentation we all deal and the fundamental principle we are knowing in this video that the govern behavior of objects under the influence of forces and all the things. Okay, okay. Now we are knowing the things, and the second one is I'm going to the second slide and the introduction to engineering mechanics. So basically the engineering mechanics. So engineering mechanics is the study of forces and their effects on objects. Basically we are studying in engineering mechanics the forces and their effects on the objects basically, and the laying the foundation for understanding how structures, machine and system behaves like that. And the key applications of engineering mechanics is structure analysis and the machine design and the robotics and the aerospace engineering. There are the four key applications जो हम जानते हैं engineering mechanics में. Okay, now the fundamental principle of statics in engineering mechanics basically. So first of all, equilibrium we are knowing. In statics we examine objects at rest, and the where the sum all forces and moments and acting them is zero when the condition and the object is equilibrium and the rigid body is also equilibrium, then we have the all the forces and the moments acting on the particles is zero. Now, and the free body diagrams in engineering mechanics, we have a critical tool for understanding the forces acting on an object and isolating it from our surroundings and representing all the forces. There are the measures. And now the statics in practice. So basically in engineering mechanics, and the statics is in practice, basically the applications include analyzing bridge structures and the ensuring stability of buildings and the design and the safe machine. These are the statics in practice. They are the fundamental principles of statics in civil engineering, the equilibrium, the free body diagram, and the statics in practice. Okay. Now the force system and the free body diagrams we have discussed in engineering mechanics. The force systems and the free body diagrams, the types of forces. So basically, forces can be categorized as the concentrated forces, distributed forces, applied forces, and each forces have a unique impact on the system. Now the second one is free body diagram. So basically representing the force acting on a body in isolation helps to visualize a equilibrium condition. The free body diagrams, the forces system and free body diagram. Now the understanding force system. So basically this understanding the enables and the enables us to predict how a system will respond, and the various loads are designed to the withstand them. They are the four systems and the free body diagram. Now the equilibrium of particles and the rigid bodies. We are knowing the equilibrium of particle and the rigid body. So basically conditions of equilibrium. So basically force at a particle to be in equilibrium. The sum of all forces acting on GD we have discussed in previous slide. Now the rigid body diagram we have a for a rigid body to be in equilibrium, both the sum forces and the sum of the all moments are equal to zero. And the application engineering basically including equilibrium is crucial structural analysis and design of prevent and the mental sustainability. Okay. Now the distributor of forces and center of gravity. So basically in engineering mechanics, the applied we have seen here in these pictures, religious and distributions and all the forces acting on the force entry and the bricks behavior, then forces acting on the particles and the force acting on the gravity and the prevent of cartilage. So distributor forces and the system gravity here is it. Now the distributor load basically forces can be distributed over an area like the weight of a beam or the pressure on a force and equilibrium analysis of determining the resultant force. Now the next one is center of gravity. So basically center of gravity, the center of gravity is point where the entire weight of the body is acting on the particles and the subject of the body is called center of gravity. Now the application in design for distributor forces and center of gravity. So basically it's determining the center of gravity is crucial for stability and for ensuring the structures. Okay. Now the friction and application engineering. So basically we have seen there is physical, there is normal body, then the forces body. Where is the normal body to apply the forces and the acting on the against body to be connected the forces will be regains. And the frictions and applications we have seen here in this slide. Now, now the static friction. What is static friction? So basically the force and the prevents an object from moving when in contact with a surface resisting the initiation motion is called a static friction. Now the kinetic friction. So kinetic friction is the opposite. The motions of an object are already moving relative to surface, slowing it down. Now the applications in friction applications. So basically the friction plays a wide role to numerous application from brakes and closest to vacuum the movement of fires. Now the key kinematics of principal and rigid bodies. So basically the displacement, so basically changing position of one object to the another object to a specific during of a time, and the measured if the vector and the both magnitude and direction which have also we have know the vector quantity which have magnitude and direction are both. And the velocity, so basically rate of change of displacements over time, rate of change of displacements over time represented as a vector quantity with both magnitude and direction. Also we have seen this, we have seen this slides. And this is acceleration, so basically rate of change of velocity over time, also vector quantity indicating how quickly velocity changes. They are the acceleration, how quickly changes. They are the kinematics particles, the displacement, the velocity, and the acceleration. And now after that, the forces, the work done, the energy applied, and the force acting on the specific body, the rigid body, the static friction, the amplitude friction, and the friction coefficient, all on and all the things in the engineering mechanics. Okay. Now the kinematics of particles, Newton's second law. So basically, as acted on the here is the key features we have said in this slide. The Newton's second law, and the Newton's second law. So basically, this fundamental law states that the acceleration of an object directly proportional to the net force acting on it. Second law क्या बोलता है कि the fundamental law, okay, that's acceleration of the particle directly proportional to a net force acting on it. And the scale law also says the formulation of the momentum P is equal to mv, mass into velocity. Now the F is equal to m, it is also the definition of the forces. So basically second law represents the forcing acting on a body object equal its mass multiplied by its acceleration. And now the third one is application. So the law is crucial in understanding and predicting the motions of the objects and the under the influence of the forces. Now the real world application of engineering mechanics. So basically we have seen in this picture the real world engineering mechanics. We have seen the all over the organization which will be dissolved. Like we have seen this in the the air breeze and the types of the buildings and the weighted and these hotels and the manufacturing plants and the villas and the airplanes and the machine machinery, the car strategy and the bridges particles. So a real world application of civil engineering. So basically civil engineering, so basically building and designs, we have used real application of engineering mechanics in civil engineering. Bridge are buildings design and the structural ability to have to check. And in mechanical energy, basically the machine design, the gear and the pulley systems, and the aerospace engineering. So basically aircraft stability we have checked, and the rocket dynamics also we have checked, and the automobile engineering. So basically the crash analysis and the suspension systems we have also the real world applications of engineering mechanics. The automobile engineering we have discussed the suspension joints and the suspension system. Now the advanced topic in engineering mechanics. So there is the advanced topics in engineering mechanics. We have see here the computational mechanics. There are the finite element analysis, FEA, the methods. We have discussed in mechanical engineering and civil engineering also. These are software called ANSYS. We have analyzed the finite element analysis and the analysis of the anything like beams, like machinery, like rebar sections, like machinery equipment, like machine designs, like other equipments, like accessories, like mobile phones, etc. Anything will be analyzed with the help of finite element analysis on axis on ANSYS software. We have analyzed all the things. Now the biomechanics, so basically application of mechanics to biological systems, and the robotics, so basically dynamics and control system which we have, and the conclusion of all the engineering mechanics. So basically the engineering mechanics is a critical field, the that underpins many engineering disciplines. Now it provides the foundation and the designing the analysis system in motor or the rest. The engineering mechanics all about. We have seen in these pictures. Now, continued advancement in computational tools and material science and expanding its application. These are the three conclusions of whole engineering mechanics. Well, we discussed the engineering mechanics, critical fundamentals, and reps, and the fundamentals of design. We have also discussed and the continued advancement in computational. So these are the video on the engineering mechanics. Hope I enjoying this video. Hope you are learned a lot. So thank you so much. Thanks for watching this video. We are meeting another video if another topic. Thank you so much. Thank you so much, guys.